Because we cannot have 0 in the numerator, so our x must be different than cube root of 3. And now when we have to find indefinite integral of our function, we will use substitution method. So let me put for x cubed minus 3u. So we have u equals x cubed minus 3. Now we have to find derivative of both sides of our equation with respect to x. So du to dx is equal, derivative of x cubed is 3x squared, and derivative of constant is 0. Now we will multiply both sides by dx because we need to find du. So dx and dx we can reduce, and we have du is equal 3x squared dx. In our expression, in numerator we have 5x squared dx, and now we have 3x squared. So what we can do? Let me rewrite our indefinite integral first, because we have 5 times x squared, so I can take this 5 before integral symbol, so we will have 5 times integral of x squared. We can put dx over x cubed minus 3. We found that du is equal 3x squared dx. We have only x squared dx, so we don't need this 3. So because we have multiplication, I will divide both sides of our equation by 3. Let me rewrite this. We have du is equal 3x squared dx. Now I divide both sides by 3. So 3 and 3 we can reduce, and I will change the sides. So it will be x squared dx is equal du over 3. So I can write 1/3 du. So now we can do substitution. X cubed minus 3 is equal u. So this is equal 5. We have to copy integral of, we have in denominator u, in numerator we have x squared dx equals 1/3 du. So this is equal 5. We have to copy times we have 1/3 integral of 1 over u with respect to u. So this is equal 5/3, and integral of 1 over u is equal natural logarithm of absolute value of u. So because we have indefinite integral, we have to add constant. We found our integral with respect to u. Now we have to unsubstitute u because we have to find integral with respect to x. So this is equal 5 over 3 natural logarithm, and we have absolute value of x cubed minus 3 because u is equal x cubed minus 3. X cubed minus 3 plus constant c. So we are finished.